go in a round. So first question is, Edison Global is a new company. Basically, it seems like you're building this architecture from scratch, but how people can use some of these principles on existing microservice architectures applications that are already.
Absolutely. So all the things you have seen are generic principle. And this framework is not touching anything specific to our domain. We were talking about services, we were talking about manipulator processors and views. Nothing of these is related to Edison Global. So yes, we're going to be using this framework. This is our reference architecture. This library is given to the world to improve it, help us to improve that framework, and be used in different domains. So you can think about this as the reference architecture. The library is implementing the reference architectures. You're going to implement the core system by providing an implementation and usage of it.
Actually, if you saw on the example, our example is about a wallet, which is something that is applicable to many different domains. The only thing you might need to change is a little bit, obviously, your model for your domain and what are the behaviors that you want to put in place for that particular system.
Cool. So second question is, what's the maturity of the open source framework, whether it's ready for production?
Very good. My answer is not ready for production. You are not ready in production until you are in production. So we're getting there. Yes, we are making some element more mature. There is one element I didn't want to cover here, which is the Saga. How we're going to implement Saga. This framework didn't cover that part yet. We have an idea how we want to do it. We have an implementation reference, but we want to build a nice DSL which is going to be effective. So I think the framework is going to have a limited initial use case where is our comfortable area, and then with the open source community we will try to tackle more and more complex elements, such, for example, Saga.
Okay, and the last question we have, Doc, is what are the main problems that you see on the framework today?
Well,
I leave it to you to talk about problems. The hard part is
I would say the main one at the moment is to be able to port it to different deployment system. So, for example, at the moment we are not using things like Kubernetes, for example. We could abstract the way that we can deploy those microservices into different cloud providers or even premises, but that's not quite ready yet. And actually, the Saga thing is quite a nice challenge to have. And we are more than keen to speak to whoever wants to contribute in order to overcome those kind of challenges. Everything in distributed system, not everything, but many things in distributed systems is a challenge, and we love facing those challenges. So I think if we face them together, it's going to be much better.
Okay, we have one new question. This one is, why should I use your framework instead of playing Akka?
Why you shouldn't? Look, it's built on top of Akka. Akka is a powerful framework. We built an opinionated framework on top of that. We introduced the concept of processor views pure function to describe the behavior. It means it's better. No, we actually are reducing the powerful of the framework to be more specific in certain problems. So I believe to solve problems like this, of course you can do in Akka, but you're going to spend much less time using the framework. But if you have more broader problems, Akka is the system that you can use. So every framework allows you to simplify the models, but reduce the scope of solution you can apply. If you think you have a domain-driven design systems, if you are using bounded context, if you are using agile teams, which we didn't speak about that, so just 2 minutes to tell this, which I really like about this framework. You know this concept of bounded context, domain expert, microservices systems? It fits very well with the agile movement, because the domain expert, product owner, and business analysts, they know the domain elements. And the agile team and development team deliver the microservices to describe all this behavior. And in your company, you have many of these teams, which they match almost one-to-one the bounded context. So that's what I like, and I like to say this is reflecting the Conway law. You're building your system which reflects the way your company is organized. So in conclusion, to answer the questions, this is a framework that's going to help you to implement domain-driven design systems using a functional and declarative approach. is built on top of akka. So everything that we can build with this framework, you certainly can do in akka, and you can do much more. But this framework helps you to solve this specific problem with less code and a more declarative way.
Any other questions? Okay.
I think gentleman over there.
Yeah.
Let me know if you want to answer the question.
That's fine.
Okay, so a question is, I think you already solved the question. Thing is, how do you solve the flow of the commands in your application?
So
because that's in my opinion one of the main problems with akka.
Yeah,
you can start sending messages through the actors, but you never know how is that going to end up. You can have actors that react to events that.
Correct. So the way this is implemented under the hood in the framework is actually having an actor per root aggregate, essentially. So that is controlling the concurrency of the different commands, requests, and so on and so forth. So as you were saying on the stateful services, if you have on the signature you have an input state and an input, and then an output and the output state. Obviously, that's handled within that actor that we have underneath that we implemented on the framework, and we control, for example, things like if you're actually running on a command, do not serve the next command until that one is finished. Also, another thing that we have in place on the framework is the persistence. So until those changes are not persistent, until a change for a command, for example, is not persisted and the event is emitted, we don't go and process the next command, which doesn't mean that we are blocked. We are not blocking at any point, but it means that we keep control of the concurrency behind the scenes for you.
So we preserve the order at the processor level, essentially. Each actor represents the processor. Their mailbox is the element that's gonna make respect the order. And the way you create processor and distribute processor is through the descriptors that Jose presented before. And let me tell you, this goes very well with the domain-driven design principle, because the root aggregate is the element of your business atomicity that is preserving the consistency of your system. And alongside with this, we also have to say we have implemented protocol to guarantee that the messages are delivered. So we have some elements which have semantic at least once with idempotency to make sure the message is processed exactly once. And we have other part of the framework that needs to be more performant, which are semantic at most once. The read side that doesn't compromise the consistency is at most once. The write model of the processors is at least once. Did I answer your questions? Or? Okay, then come and grab us. We love to talk about that.
Yeah, we ran out of time, so but they have a booth here, so I'm sure they will be happy to answer any questions you may have there.
Thank you very much, guys,
Cheers.
and enjoy
Thank
the
you.
conference.